aware of matrix and its basic operations like addition, subtraction, and multiplication of matrices. These operations must be carried out on two matrices. However, some operations must be performed within a matrix. Matrix operations of this type are referred to as elementary matrix operation. And in this video, we are dealing with such operations. Elementary operations are operations that are performed on a matrix in elementary arithmetic, namely addition, subtraction, multiplication, and division. Elementary operations for matrices play an essential role in determining the inverse of a matrix and also in solving a linear system of equations. They can be used for a variety of other calculations as well. Matrix on which the elementary operations can be performed is called an elementary matrix. There are mainly two types of elementary matrix operations, that is, they are elementary row operations and elementary column operations. The first one, that is elementary row operations, are operations that are performed on a rows of the matrix. While the second one, elementary column operations, are operations which are performed on the columns of the matrix. There are mainly three basic transformations or operations that can be done on a matrix. First one, that is row or column interchanging transformation. This type of transformation aims at interchanging a row or column within the matrix with another row or column. That is, interchange of I and jth row is represented by Ri tends to Rj, and the interchange of column is represented by Ci tends to Cj. Consider, for instance, A is equal to matrix 3 4 1 7 8 minus 2 minus 9 0 1. Applying the interchange to R1 and R3, we get A is equal to minus 901 78 minus 2 341. So the row 1 and row 3 are interchanged. Second one, that is row or column scaling transformation. In this kind of transformation, the main purpose is to scale a row or column in which a non-zero number k is multiplied with the elements of the ith row and is given by Ri becomes k times Ri, and the corresponding column operation is given by Ci becomes k times Ci. Consider the same matrix. Matrix A is equal to 3 4 1 7 8 minus 2 minus 9 0 1. So R2 becomes minus 4 R2, and we get A is equal to 3 4 1 minus 28 minus 32 8, and the third row minus 9 0 1. As you can see, the change is reflected only in the second row. Now comes to this third transformation, that is row or column addition transformation. Here in this particular transformation, a row can be replaced by the sum of that row and a multiple of another row. And this is represented by Ri becomes Ri plus k times Rj. Here it implies jth row is multiplied by a constant k and then it is added to the ith row, and its corresponding column operation is given by Ci becomes Ci plus k into Cj. Remember that this transformation affects only that specific row or column. Consider, for instance, matrix B is equal to 2 5 minus 3 4. Now applying R2 becomes R2 minus 2 times R1 to the matrix B. So first we need to multiply each entries in row 1 with minus 2, and then we add it to the row 2. That means minus 2 into 2 5 plus minus 3 4, which is equal to, we get it as the matrix B is equal to 2 5 minus 7 minus 6. As you can see, there will be no change in the elements of row 1, while the change is reflected only in the second row. With that, we have covered everything there is to know about the elementary matrix operations. In the following video, we will look at how these elementary matrix operations can be utilized to find the inverse of a matrix. Now, let's have a quick recap of the entire discussion.
Manorama Horizon. Learning made simple.